In this video, we will come up with our own exponential growth model for a given contextual situation. We're talking about a growth of a colony of mosquitoes. The population of a colony of mosquitoes obeys the law of uninhibited exponential growth. Notice that no equation has been given in the original prompt. Question A, if n is the population of the colony and t is the time in days, express n as a function of t. So we're going to write our general form for an exponential function. N of t is equal to a sub 0 times e raised to the power of rt, where a sub 0 is the initial amount of mosquitoes, r is the rate of growth, so we're expecting r to be positive. T is given as the time in days, and n is given as the population of the colony. Part B, if there are 1,000 mosquitoes initially, and there are 1,800 after 1 day, what is the size of the colony after 3 days? The first thing we need to do is solve for the rate of decay by substituting the given information into our general form of our equation from part A. So we'll have 1,800 is equal to 1,000 times e raised to the power of 1r. Make sure you see where those numbers came from. Now to solve for r, we're going to divide both sides by 1,000. Let's simplify our equation. And now let's take the natural log of both sides. So my right-hand side becomes r is equal to the natural log of 1.8. Now that will be an exact answer, which we can estimate to approximately 0.588. Now that we have 0.588 as the rate, we're going to substitute that and determine n of 3. So remember, we're substituting t for 3 and r for really the exact value, remember, was the natural log of 1.8. Now this is a number which we can evaluate with our calculator, and we get about 5,832. Now we always want to make sure that this makes sense in the context of the problem. Remember, we had an initial amount of 1,000 mosquitoes. There were 1,800 after 1 day. We're saying that after 3 days, there'll be about 5,832 mosquitoes. That does make sense. You always want to check. Part C, how long is it until there are 10,000 mosquitoes? Well, obviously it's going to be more than 3 days, right? So what we're going to do is substitute into our equation all the information for every variable except t, because we want to know how long until there are 10,000 mosquitoes. So 10,000 is going to be my n, my population of the colony. My initial amount is still 1,000. My rate is still natural log of 1.8. T is the only variable that I'm leaving not substituted for, because that's what I'm solving for. We can simplify this equation by dividing both sides by 1,000. We can take the natural log of both sides. My right-hand side becomes natural log of 1.8 times t. My left-hand side remains natural log of 10. To solve for t, I can divide by natural log of 1.8 to both sides. So that's my exact time where there'll be 10,000 mosquitoes expected. I can now take a calculator and estimate this to be about 3.91. So there'll be 10,000 mosquitoes in about 3.91 days.